the last session, we were talking about how to design an isolated footings, and then we have talked about the combined footing design as well. So in this particular session, we are going to talk about how to design a strap footing. Okay, design of strap footing. So this would be the last one in the design process with respect to the software analysis. So once after this gets completed, I'll be talking about the soil investigation report, and with that, our sessions will get end. So mostly by Monday, we can complete our training, right? So now let us understand why we need to design, or in which cases we will design the strap footing. Suppose, especially when we are designing the isolated footing or isolated foundation, we will follow one principle, which is that whenever we have to position our column, we need to position our columns in such a way that the center of gravity of the column should coincide with the center of gravity of the load. So the center of gravity of the column should coincide with the center of gravity of the load. Why? What will happen if the center of gravity of the column and the load gets coincide? What will happen is the upward soil pressure, whatever that will be there, that will be uniformly distributed. And whatever the settlement that is available, that settlement will also be uniformly there throughout the foundation. Whenever we have the center of gravity of the load and the center of gravity of the column, if these two gets coincided, then the uniform settlement and also the upward soil pressure will also be uniform. So for these reasons, we will maintain the center of gravity factor. But in some situations, okay, every time it is not possible to coincide both the center of gravity of the load and the center of gravity of the foundation or the column. So it is not possible. So there are some situations, or there will be some situations, when we fail to maintain the coinciding of center of gravity of the column and the foundation and the load. So this problem arises. What happens is the overturning of a foundation will happen. So to overcome this, or to overcome the overturning of the foundations, we will design the strap footing. So that's the simple idea of why we need to design strap footing. So as we have discussed already in the manual design process, so the same problem statement we are going to take, which is with two columns having cross section 240 by 240 and 300 by 300, and both the columns are loaded with 300 and 500 kilonewtons. So the center to center distance between the column is given as 4 meters, and the SBC of soil is 100 kilonewtons per square meter. And now we need to design a combined footing by using the strap beam and making sure that the width of the foundation is limited to 2 meters by using M20 and Fe415 grade of steel. So this is the problem statement. So how actually the strap footing will looks like? So strap footing looks like in this way. Suppose, let's say the strap footing design may goes in this way. Suppose here you have one footing or one foundation, and here you will have one more foundation. Okay, so where the columns will be available inside both of these foundations. Okay, the columns will be available. So for one column, or sorry, for one footing or foundation, the column might be at the center, and for another foundation, the column might be there somewhere like this. Okay, somewhere like this. Now in these cases, what will happen? The center of gravities will not get coincided. So since the center of gravities will not get coincided, what we do is, whatever the nearest foundation that is available, or whatever the nearest footing that is available, for that footing, we are going to connect a beam. We are going to design a beam in a way that to connect these two. So when you connect these two, what will happen is, whatever the load that is coming onto this column will get equally distributed by using this particular beam. And this beam is called as strap beam. That's the whole idea of designing a strap beam. So you can consider this as a footing 1 and this as the footing 2. And as given in the problem statement, the width of the foundation is limited to 2 meters. This is what it is given in the problem statement. Okay, let us consider it in this way. So now we need to design this strap beam. Okay, we will design this strap beam. So first we are going to model the foundation, and then we are going to model the column, and connecting these two columns in the foundation, we are going to model the strap beam. So this will be little lengthy process because we need to do multiple things, or we need to consider multiple things here. So let me start the design process. So let us open the SAFE software or SAFE model. So here, what I'll do is I'll just go and open a new model. So file, click on new model, and then design code is IS456-2000. And then here, what we are going to do is we are going to work in this way, or maybe let's say, okay, anyways, let it be like this only, no problem. Or I can use the square footing model also. There is no problem with that because, however, the foundation, the columns are square only. So let me open the square footing models. Just give me a second. New model, and then here it is, yeah, isolated square footing. This one I'm going to work with. Okay, so make sure to select the IS456 code, and then units also make sure they should be the metric defaults. Click OK, and then the design preferences, you can click here and you can check the conditions, and a minimum cover to the slabs, that is also fine. Okay, so click OK and then select blank. Right, so we can also model by using by starting from the beginning also, but I'm just using it because since I already have the existing model, because these are also the square columns. Okay, here you can see the square columns with square footings. Right, so now let us draw a point. So just go to draw and then click on draw points. Okay, draw points, and the plan offset is x along x and y is 0, and we are going to type it, we are going to make a point. So click on anywhere in the window and let's draw footing around this point. So here I'm drawing a point here, you can see. So now let us draw the footing around this point, around this particular point. Let us draw the footing. Suppose if you see the size of footing, so how will you calculate size of the footing? So size of the footing S equals to, okay, the load coming onto the footing. Okay, the load coming onto the footing. Suppose let's say I want to design the footing 1. Okay, I want to design footing 1. So the size of footing equals to total load onto the footing, that is 300 kilonewtons, which is there in the problem statement. You can see here. So on the first footing, the load is 300, and on the second footing, the load is 500 kilonewtons. Right. So 300 kilonewtons divided by SBC or soil, which is 100. Okay, let me go with, so 300 upon 100 will give us 3 square meters. Okay, this is the size of the footing. So if you want to find the dimensions, okay, how will you find the dimensions? Root 3. Okay, so since it's a square, I'm making it as root 3, that will be 1.73 meters. Okay, 1.73 meters. So now let us draw a point, let us draw area around this point, that is the footing area around this point with a size of 1.73 meters. Okay, with a size of 1.73 meters along y-axis. Okay, right. So let us do that. So how will you draw an area around a point? So we have this option which is called as, sorry, we have this option which is called as quick draw areas around a point. So this one. Okay, quick draw areas around points. So click on that one, which is quick draw areas around points. And here, let us select the condition. So it's a slab, and we are let it be rectangular slab, and then select the FT600 M20. Now you might have a confusion how this came, because I have opened the model which is already available with respect to the square footing design. So that's why all these properties are available, readily available now. Okay, right. So on the X dimension is 1.73 meters, and Y dimension is also 1.73 meters. Why it is 1.73? Because the width, for square footing, the sides will be same. So that's why I am going with 1.73 and 1.73. Right. So now just click on the center point so that the foundation will be modeled, or the square footing will be modeled. Right. Can you see the square footing? Right. So that's how you can model the square footing. Right. So now what we will do is, let us draw one couple of more points. So let us draw a couple of more points. Let us draw the stiff area for this portion. Okay, let us draw the stiff area for this portion. So in order to draw the stiff area for this portion, again, go to quick draw areas around points. And now here in the type of object, it is slab, and the shape is rectangular slab. And here the property is, we are going to model the stiff area. Okay, we are going to model the stiff area. So what will be the dimensions of the stiff area? Whatever is the dimension of the column. Okay, whatever is the dimension of the column, that will be the dimension of your stiff area. So currently I'm modeling on the first footing. So what is the dimension of the first column? 240 by 240 mm. So that will be 0.24 meters and 0.24 meters. Right. So That's it. So now just click on the midpoint. So if you want to zoom it, you can zoom also. Make sure of that. And then once you highlight the midpoint, just click on that. Okay. So once you click here, you will see the stiff area. Right. So this is our stiff area. So the small square is the stiff area. So now let us assign the loading part. Okay, let us do the loading conditions or load, let us assign. So in order to assign the load, we need to first select the point on whichever we have to assign the load. So on the stiff area point, I want to assign the load. So select that midpoint. Okay, select the midpoint and then go to assign load data and then point loads. So click on that. And here it's a live load condition and X and Y is 0 and the load on first footing or first column is 300 kilonewtons. You can check here. Okay, on column 1, the load is 300 kilonewtons. Right. So that's what I have given. And the moment, that is all 0, and the X and Y dimensions, that is the first column dimensions, that is 240 mm and 240 mm. Okay, you can go with replace existing loads or add to existing loads. So you can go with replace with existing loads if there are any loads by any chance. Okay, right. So now I have applied the load. Okay, this is how you can apply the loads. So once you see the red circle here, that indicates we have assigned the loads. Now here in the problem statement, let us consider the maximum settlement. Okay, the maximum settlement in the foundation as 25 mm. Okay, maximum settlement in the foundation as 25 mm. That's the usual settlement value that we consider. Okay, 25 mm is the settlement that we'll consider. Right. So in order to find out upward soil pressure, so how will you find out the upward soil pressure? The K value, that is SBC of soil, which is 100 divided by the settlement, which is 0.025 meters. I'm just converting that 25 mm into meters. So whatever the value that you are going to get here, that is called as upward soil pressure. Okay. So now let us give that soil subgrade properties. Okay, let us give that soil subgrade properties, which is K. Right. So how will you assign the soil subgrade properties? So just go to define. Okay, first let us define that. Define and then soil subgrade property. Okay, and then select SBC 200 at the rate 25 mm. So we need to modify this one because in our case the SBC value is 100. It is not 200. You can see here it is 100. So let me give it as, let me modify or show property, or if you want you can add a new property also by clicking on add new property. Right. So modify or show property, and here what I'll do is I'll change this 200 to 100 and then the subgrade modulus. Okay, the subgrade modulus, how will you calculate? So the SBC of soil divided by the settlement, the allowable settlement, which is 100 by 0.025, and then click enter, you will see the subgrade modulus value, which is K, and then compression only, click OK, right, and then OK. So we have defined the soil subgrade property. So now let us assign the soil subgrade property to the foundation. So foundation is which one? The bigger square is the foundation. So select the slab. So you can see at the bottom left side, which is one area, 4 edges selected. Right. So select the slab first and then go to assign. Okay. In the assign, we need to assign the support data, which is basically the soil property. So click on that and then select the soil subgrade property that you have defined. Select that and then click OK. So once you click OK, you will see the green color plus symbols, which indicates the soil subgrade modulus has been successfully applied. Right. So now with this, let us run the analysis. Okay, let us run the analysis and let's check the upward soil pressure, punching shear and settlement, whether these are within the limits or not. Right. So let me click on run analysis. So since I have not saved the model, it will ask me to save the model. So let me save the model as a model 4. It is basically the strap footing design. Right. So once you save the model successfully, the analysis will get completed. And once the analysis gets completed, we are going to check the upward soil pressure. So how will you check the upward soil pressure? So here in the quick access bar, you can see show reaction forces. So click on show reaction forces and then the load cases, select, make sure to select the service load combinations, which is dead load plus live load. And then check for the soil pressure and then let all these things be default values, click apply, close it. So how to check the upward soil pressure? So if you see here, what is the value at the center? It is minus 115.13. Whether it is safe or not. How will we define whether it is safe or not? it should be less than the SBC of the soil. What is SBC of the soil? 100 kilonewtons per square meter. What is the value that we are getting at the center? It is minus 115, which is greater value. That means it's unsafe. Okay, that means it's unsafe. Why it is happening so? But if you go towards the center, I mean towards the end, the value is getting decreased to a slight extent. You can see at the center the value is minus 115.42, but when you move away from the center on any side, the value will be reducing it to 115.01. You can see at corners also. At corners it got much more reduced, which is 114.97. So likewise, it is going to get reduced. So now the question is, it is unsafe. Okay, minus 115 is greater than the SBC of soil, which is provided in the question, that is 100. Okay, so it's unsafe. So why this is happening? This is because while calculating the size, okay, while calculating the size, we have not taken 10% of the column load. Okay, while calculating the size, so I told you, so how we calculated the size of the footing? So size of the footing S equals to, okay, total load on the first column, that is 300 kilonewtons, divided by SBC of soil, which is 100. So I directly have taken the total load. We have not considered the value of self weight of the footing. How to calculate the self weight of footing? So total load plus the self weight of the footing is 10% of the column load. Okay, 10% of column load, that is 300. So 10% of 300 is 30. So that therefore the total load will be 330 kilonewtons. So this is the load that we should have considered while calculating the size of the footing. But instead, what we have done, we have directly taken only the load. We have not considered the self weight of the footing. So that's the reason why we got this error. Okay, why at the center the value is 115, that is more than 100. Okay, so if you solve this one, that is 330 by 100 will give you 3.3 square meters. So if you want to find out the size of the footing, it will be around 1.81 meters. So this will be the size of the footing. But for what we have designed, in our case, it is much, I mean, it is the value of the size of the footing is, it is 1.73. Okay, currently our footing size is 1.73. Let us check. So how will you check the size? So here you can see draw dimension lines. So just click on that, and here just keep the cursor here and then move to the other end. Can you see what is the value? That is 1.73 meters. Okay, 1.73 meters. So now what we have to do, we have to modify this particular size to this value, which is 1.81 meters. Then we will avoid that greater value, which is 114 or 115, whatever value that we are getting. Right. So let us do that. So what is the modified value? Modified value is 1.21. Remember that. Okay, modified value is 1.21. Right. So now, right. So now what we will do, so since we need to do some corrections, first we need to unlock the model. So just click on unlock the model in the quick access bar and then click OK. Right. So now select the bigger size of the slab, because this is what we need to modify. Okay, we select the bigger size of the slab, and then I will delete this one. Currently, it's not required for me because the dimensions are not as per the requirement. So let me delete it. Right. Okay. So just select the slab and then click delete on your keyboard. Right. So now let us define the slab properties. So just go to define and then slab properties, and here FT600 M20. Okay, so we have to modify this one. So suppose let's say I'll go with FT450 mm. So the depth of the footing will consider it as 450 mm. I'll just do a trial and error method. We'll check. So why to follow every time the same concept here? So let me do the trial and error method. Right. So select that one and then I'll click on modify or show property. So now let us change it to 450 mm. Right, 450 mm and M20 grade of concrete, and the slab material is M20 and the type is footing, and here the thickness should be 450 mm. Right, let me go with 450 mm. Even I don't know, so we need to do the trial and error. That's how in the real time we'll work. Okay, we don't get exact values. Okay, we need to do trial and error method. So click OK and then OK. Right. So now what we will do, we will draw area around a point. So because we have to draw the footing. So currently this is not footing. This is only the stiff portion or the stiff area. So how to draw an area around a point? So we have this one, which is called as quick draw areas around point. And here select it as slab and it's rectangular slab. Okay. And the property is not stiff, it is FT 450 M20. Okay. And the size of the foundation is 1.81, modified one. Okay. 330 by 100 has given us 3.3 square meters. Root 3.3 is 1.81. So that's what I'm doing here. Right. So once you have selected all the points, now what we have to do is click on the smaller square. Okay, the midpoint of the small square, whichever is the midpoint that is there, click on that, and then you will see the footing around the square, around the column or the square column, you can see. Right. So this is our square column. So now just keep the cursor on the bigger square. Okay, that is the foundation. Okay, keep the cursor on the bigger square and then right click it. Right. So now you can see which portion has got selected. The foundation has got selected, right? Now what we have to do is, so here a dialog box appears. You can see slab type area object information. So just select none here. So soil property, which is selected, it is showing as none. Okay, so it's soil property we have to give. So click on none and then select the soils upgrade property, which is SBC 100 @ 25 mm, and then click OK. Okay, and then click OK, so that we have applied the soils upgrade property. Right. So now what we have to do is, let us run the analysis once again. So let me click on run analysis. So once the analysis is completed, so let us check the soils upgrade property, or that is upward soil pressure. Okay. So click on upward soil pressure. The load combination is dead load plus live load, and then select soil pressure, and then let the default things be as it is, and then click apply and close it. Right. So now let us see. Now can you see what is the value that is coming down? It is 103.18. Earlier, what was the value? As far as I remember, it was about 115. Okay, it was about 115 in the first case. Now in the second case, what is the value now? It is 103.18. So now have we reduced the intensity or not? How we have reduced the intensity? We have increased the width of the footing. That's what the first thing that we have done. And the second thing is we have increased the depth of the footing. Sorry, we have decreased the depth of the footing. So in the first case, the depth of the footing was 600 mm, if you remember. Okay, since when I'm keeping 600 mm as the depth of the footing, I'm not getting safe value with respect to the upward soil pressure. So what I have done, I have reduced this depth of the footing to 450 mm. So when I reduced the depth to 450 mm, the soils upgrade pressure or upward soil pressure, I have minimized it. Okay, it is at least close to 100. 103 is at least close to 100 than when you compare with 150. But still, however, so we still have to modify this one. So we cannot neglect that. So since 100 and 103 are close to each other, let us not bother about it. No, it's not that way. So we'll still try to reduce it. How? So in order to modify this one, what we will do is let us work on the part of the width of the footing. Let me show you width or dimensions of the footing. So what is the current dimension of the footing? How to find out the current dimension? So here you can see draw dimension lines, and then click on this point and then go to here, and then you can see the dimension, which is 1.81 meters. Right. So 1.81 meters is the dimension. So we should modify the size of the footing. So how will you modify the size of the footing? So in order to modify that, so let me consider in this way. So area of the footing, that is 1.81 into 1.81, okay, into the depth of the footing. What is the depth of the footing? I have considered it as 0.45 meters. That is 450 mm depth I have considered, into unit weight of RCC, which is 25 1. Okay, so if you solve this one, the value will be 36.86 kilonewtons. Okay, 36.86 kilonewtons. So for safety considerations, what I will do is I will increase this value approximately to 50 kilonewtons. Okay, I'll increase this value approximately to 50 kilonewtons. Right. So now what is the total load on the column 1? The load on the column 1 is 300. Now instead of 10% of this column load, what I'm doing is I'm increasing the load to 50 kilonewtons. So that will be 300 plus 50. So that will be 350 kilonewtons. The total load is 350 kilonewtons. So 350, that is total load divided by SBC of soil, which is 100. So that gives you 3.5 square meters. Okay, 3.5 square meters. So root 3.5 is 1.87 meters. Okay, this is how you have to modify when you are working with, if you are not getting the upward soil pressure as safe value. So the first case is you try to decrease the depth of the footing. Even after decreasing the depth of the footing, you try to calculate the total load in this way. What is this way? Area of the footing multiplied by the depth of the footing multiplied by unit weight of RCC, that is 25. So now we need to modify this length. Currently, what is the length? It is 1.81. So this value has to be modified to 1.87, and then let us check whether the values will be safe or not. Right. So now, since we need to do some modifications, again, we need to unlock the model. Just click on unlock the model and then click OK. Right. So once this is done, so again, let me do one thing. Right. Right. So now what we will do is let us unlock, let me run the analysis once again. Just give me a second. Let me remember what is the value, because I need this for the next cases also. It is 103, so that's fine. So let me unlock the model, click on OK. Right, that's done. So now let us select the bigger square and then delete it once again. So we have to model it. Every time whenever it is not successful, we have to model it. So now quick draw areas around point. Okay, select that one. And here the type of object is a slab, the shape is rectangular, and property is FT450 M20. And here we need to change it as 1.87 instead of 1.81. 1.87. Right. So once this is done, so just move the cursor to the center point and then click, and you will see the slab that got modeled, the foundation slab that got modeled. Right. So once this is done, what we have to do? So we need to apply the pressure. So we need to apply the pressure. So how will you apply? So select the slab, the foundation slab, or just keep the cursor. Anything is fine. So and then right click. So here the soil property, it is none, nothing is applied. So click on that, select that, and then click OK, and then OK. So once the soil pressure is applied, so now what we have to do is we need to run the analysis once again. So let me click on run analysis. Right. So now let us see whether the upward soil pressure has got something reduced or not. Earlier it was 103. Now let's see whether it got reduced or what happened. Let's see. Okay. So click on upward soil pressure, load combinations, soil pressure, and then click OK, apply, close it. Now, if you see, what is the value? It is 97.42. Is it safe or not? 97.42 is less than our SBC value, which is 100 kilonewtons. So that means the upward soil pressure is within the limits. Okay, upward soil pressure is within the limit. So since upward soil pressure is within the limits, now let's check for the settlement condition. So how will you check for the settlements? So we have this option, which is called as show deformed forces. So show deformed shape. So click on that, and then the load case. Okay, the load case is, sorry, load combination we have to select, and then dead load plus live load, and then click apply and close it. So let's see the settlement. So what is the settlement? 24.35. Forget about negative symbol, it is 24.35. Why negative? Because settlement always happens towards the down. Okay, if it is happening upwards, it's called as uplift pressure. Right. So anywhere 24.35 is less than the allowable settlement, which is 25 mm. That's what we have considered. And if you move away from the center, you can see the settlement values are getting decreased. And if you move to the edge of the footing, they are getting much more reduced. Okay, so that's how the settlement values are also within the limits only. So now let's see the punching shear. So how will you check for the punching shear? So click on this one, that is show punching shear design. Okay, and then you can see the value, which is 0.2647. So how to know whether the punching shear is safe or not? If the value is less than 1, that means it's safe. So now currently the value is less than 1, it's safe. But here the condition is the face of the column. Okay, I told you in the beginning of the session, I told you one diagram where one column is there. Suppose if I draw a combined footing, one column is there at the center and another column is there at the edge of the footing. Okay, one column is there at the center and another column is at the edge of the footing. So now left edge we'll see. So let us do some corrections with respect to this positioning of the columns. So since we need to do some corrections, again, we need to unlock the model. See, as of now, the upward soil pressure, the settlement and punching shear, they're all safe. There is no problem with that. Okay. The only thing is now we need to do some corrections with respect to the positioning part. Right. So just unlock the model once again. Click OK. Right. So once you unlock the model, just go to edit. Okay. In the edit, we can see one option called let me select this one. So just go to edit, right. So select the slab, okay, select the foundation slab. Okay. So now what you have to do is just go to edit, and in the edit, we have this option which is called as move points, lines or areas. So select this one, and here the X, Y and Z values. So Z should be 0 and the value of X should be 815. So I'll tell you the reason why this 81 or how this 815 is coming. So if any of you can find out before before I tell, like, it's very good. But right. So anyways, I'll let you know. But you just keep guessing what is that 0.815 represents. So the delta X value is 0.815. Okay. And Y and Z value are 0. Okay. Right. And then click OK. Right. So once this is done, can you see what happened here? The column automatically moved to the edge. How it moved? Because I have directly the value. Earlier, the column is at the center. So in order to position the column at the edge, so I have just calculated the distance. To which distance I have to move it. So it was actually 815 mm. So that's what I have made, 0.815. That's simple. Okay. So you can see the column has moved to the edge of the square footing or the square foundation. Now, once again, let us run the analysis. Why we need to run the analysis? Because this is our actual position of the column. So let's just run the analysis and let's check all the upward soil pressure, all those things. Right. So let me click on upward soil pressure, load combinations, everything is same. Click apply, close it. Now, if you keep the cursor at the center, can you see the value is 241.73, which is much, much greater than almost 2.5 times greater than the SBC of soil. That means, is it safe or not? No, it's not safe. Okay. But if you move cursor to the right side, what is happening to the upward soil pressure? You can see the value is getting reduced to much, much lesser value. Here it is fine. Okay. In the edges, it is fine. But at the column, what is the value? It is 247. That means it is not going to be in a safe condition. So here, one thing that you have to observe is when I move towards the edge of the right edge of the footing, the negative value is going to get changed into positive value. Can you observe here? Right. Now it is positive value, 68.27. So 68.27 doesn't mean it is safe. Even though it is less than 100, it doesn't mean it is safe. Why? Because whenever the values are in positive, that means the footing will get uplifted. Okay, the footing will get uplifted. If uplifting is much more dangerous than settlement. Uplifting should never happen. Okay. If you see this, if you want to see this one in a better way, just click on 3D view. Okay. Now, can you see what is happening to the foundation? Uplift is happening or not? You can see. See, this is where the original position is. Here it is fine, but see, this entire part is uplifting. Okay, this entire part is uplifting. How much it is getting uplifted? The value you can see there. Okay, 62 some 25 or something. What is the value? It is 50 something, 68 something value is coming. So that's the impact. Okay. So now to avoid this uplifting, what we have to do, we need to connect it with a strap beam. Okay, we need to connect with a strap beam. So now let us connect this particular foundation with a strap beam. So for that, in order to connect with a strap beam, we need to have the second footing also, second footing and second column also. So now let us draw the second column. So at which distance we are going to draw? You can see the distance, the center to center distance between the column is 4 meters. So at a distance of 4 meters, we are going to draw the second column along with footing. So let me go to XY plane. Right. So now what we will do is, so we will unlock the model and then let us work with that. Okay, to avoid this uplifting, we need to provide the strap line. So first let me unlock the model, click unlock and then click OK. Right. So we have unlocked the model. So now let us draw the second column at a distance of 4 meters. So first let us define the point. So just go to draw and then draw points. Okay. So now we need to draw a point at a distance of 4 meters. So the X distance is 4 meters, right? So now what you can do is click on center point of the column. Okay. The first column, whichever that is there, and then click there. So at a distance of 4 meters, can you see? At a distance of 4 meters, another column or another point has been modeled. You can see a point drawn automatically. So here the limitation is width of the footing. So what is the width of limited width of the footing? So it is clearly said that the footing width has to be limited to 2 meters. So now let us work with this part also. Okay, since width is fixed, so let's make the width of the footing as 2 meters. Length can be anything. Okay, the length of the footing can be anything, but width has to be limited to 2 meters. Right. So now what we will do, let us draw a point of 2 meters. So just go to draw and then draw points. Right. So draw points, and then we need to draw the width of the footing at a distance of 2 meters. So this is how the width will be. Okay, this width is 2 meters. Now, instead of 2 meters, what I'll do is from midpoint, we need to draw a line. So from midpoint, what will be the distance? It is 1 meter distance. Okay, this point will be 1 meter distance. Somewhere here, one point will come. So that will be at a distance of 1 meter. So now let us draw that one. So y value will be 1 meter now. Okay, y value will be positive 1. Okay, if you give negative 1, it will come downwards. I'll show you that. So I have given the y value as 1. Now click on the midpoint of this one. Okay, click on midpoint of this one, or you can click on here also. Okay, you can click the midpoint of the already modeled footing as well. Okay, column. So click on midpoint of this small square on left side. Okay, whichever that is there on the left side. So click on it. Now can you see where it got modeled? Okay, you can see you will see a point somewhere here, but is it fine? No, it's not fine. Why? Because this is not where we have to model. Okay, we have to model somewhere here. So let me undo this part and then give this one and click here. Right. Now can you see the 4 meters distance? No, sorry, at a distance of 1 meters. Now similarly, we have to draw one more point at the bottom as well. So let me give it as -1 and then click here so that you can see another point which is modeled here. Right. So now you will see a point both on upside and downside. So now what we have to draw, if you see, okay, if you see the, let me show you that one. Right. If you see this point, okay, this point, and if you draw a straight line, okay, if you draw a straight line, obviously they will not be having same width. Okay, you can see there is a distance. Okay, this distance we have to increase. So actually, what is this distance? Let me show you that. So actually, this distance should be the overall width of the footing should be 2 meters. But what is the actual width currently that we have? Let me show you that. It is 1.87 meters. Can you see? It is 1.87. So we have to increase this one. So that's why first what I have done was I have modeled the point by with reference to here, and the point came somewhere here. Then after that, I told that, no, it's not here. It should be here. So actually, I did in a 2 ways. Okay, that's actually wrong, whatever I have done so far. So let me select that one and let me undo all the parts, whatever that we have done. Right. So let it be like this. So now let us draw a point at a distance of 1 meter. So just go to draw. Okay, draw point, and then the y distance is 1 meter. Right. So and then click here. Right, you can see a point here and then give the y value as -1 to draw the point at the bottom. That will be -1, right? And then click on this point and you can see one more point here, -1 meter, right? So now you can see the 2 points are modeled. So now we need to modify this length. So how will you modify this length? So we have this option which is called as reshape object. Okay, reshape object. So click on reshape, this one, reshape object, and then click on the slab. Okay, click on the slab. Once you click on the slab, you should see these diamond symbols. Okay, diamond symbols at the center and circles at the corners. Once you see this one, so drag the bottom portion of footing till it reaches to this point. Okay, drag the bottom portion of the footing till it reaches to this particular point. So first let me drag the bottom portion, right? That's done. So similarly, drag the top portion as well. Okay. Make sure the point has to perfectly coincide, right? So this is how we can reshape the member. Okay, this is how we can reshape the member, right? So now if you want to, if you have any confusion whether this length is 2 meters or not, just select this one, draw dimension lines, click on first point and then click on second point, and then you can see what is the dimension, 2 meters. So that's fine. So the width of the footing is modeled. So now what we will do is, now as per manual calculations, the span of the footing, let me show you what is the span of the footing. What is that? Let me check that. Right. So you can see, as per manual calculations, the span of the footing, that is length of the footing, is 2.2 meters. Width is fine. Width is 2 meters only. That's fine. And the span is 2.2 meters. So let me take this value and do the trial and error method. So let me go to draw. Let me deselect this one. Let me go to draw points, and then here it is at a distance 2.2 meters. So let me give it as 2.2. That's the total length of the footing. Okay, 2.2 meters. And then click on the corner plus symbol at bottom left. This one. Okay, click on the corner plus symbol at bottom left. Right. So once you click on that, you will see a new point at the right side of the footing. Let me show you that. Can you see? A new point has come. So what you have to do, click on the corner right point, corner left point. Okay, keep the cursor at the corner left point, this plus symbol, and then click on it. And you will see a new point on the right side of the footing. So now what we have to do, we need to extend this footing along the length. Why? Because what is the dimension? What is the current dimension of the footing? Let me show you that. So click here and then click here. And now what is the current length? It is 1.87. So we need to increase it to 2.2 meters. That's what here it is said. 2.2 meters is the length. Remember, there is no restriction with respect to the length of the footing. The only restriction is with respect to the width. So that's why I'm doing this one. Right. So now what we will do is, let me undo this one. Right. So what we will do is, we have got a new point. So now let's reshape it. So click on reshape object. Once you click on reshape object, and then click on the footing, and now select any particular point and drag up to this newly created point. So select any particular point and drag up to the newly created point. Right. So once that is done, fine. Okay. So click on any symbol and drag it till it reaches to the newly formed point. Now let us check one more time whether this dimension will be fine or not. Okay. So let me go to draw dimension lines, click on the first point and then move to the second point. Now, can you see what is the length? 2.2 meters. So here also it is 2.2 meters. So we have defined the length and width of the first footing. Okay, now let's draw the second footing. Okay, let us draw the second footing. Right. So in order to draw the second footing, so just to click on, we have already drawn the point. You can see here, this point we have already drawn. Okay, around this point we have to draw the areas now. Right. So let us do that. So now click on quick draw areas around points. Right. So with this, now what we have to do, select the shape type as slab, shape rectangle, and then footing type is FT450. And here it is, the X dimension is 2.2 meters and Y dimension is also 2.2 meters. Because whatever the length of this footing, that will be the same length for another footing as well. So that's why I have given 2.2 meters. Sorry, Y value is 2 meters. Width is 2 meters only. Okay, width is 2 meters and length is 2.2 meters. Right. So now what you have to do, just click on the symbol here, plus symbol or the point. Okay. So now if you click here, you can see the second footing, right? So that's how you can model the second one. So now let me select this one, right? So now select the newly created foundation slab, and on this one, we are going to apply the soil property. So select the newly slab, okay, and then right click, and here the soil property we have to apply. Soil property, click on none, select the one that we have defined, click OK, and then OK. Right, you can see the soil property also has been applied. Okay, so now let's model the column in the second footing. So we have not modeled the column, right? So let us model that. So again, we need to draw a area around point. So we have a point already. Now let us draw the column area around that point. So quick draw areas around point, and here let us select the slab. Okay, shape is rectangle, and here we need to do the stiff portion. Okay, we need to do the stiff area. So the property is stiff area, and the dimension of the second column. What is the dimension of the second column? It is, let me see that. Right, it is 300 by 300 mm. So let me give 300 mm, that is 0.3 meters. 0.3 meters, right? So once this is done, okay, just click on the midpoint in the second footing. You can see the column. That's actually the stiff area or the square column, right? So now let's assign the load also for the second one. Okay, for the second one, let us assign the load. So first, how will you assign? First, select the point, whichever you want to assign the load. Okay, and then go to assign load data point loads, and then select the live load, and then the load on the second column. What is the load on second column? It is 500 kilonewtons. You can see here, right? So let me give it as 500 instead of 300. Okay, and make sure to select add to existing loads. Don't select replace existing loads. If you select this one, whatever load that is applied on the first footing, that will get replaced. So make sure of that one. Okay, so if you have any loads, if you have already applied any loads, make sure to select this add to existing loads. And then the x and y dimension. What is this x and y dimension? The dimension of the footing, which is the dimension of the column, second column, that is 300 by 300 mm. So, and then click on add to existing loads, click on OK. Right. So we have assigned the loads also. So once you assign the loads, you will see this red circle. So if you want to see it in a 3D view, let me click on 3D view. And now you can see on both footings, we have on both columns, we have the load. On the first column, we have 300 kilonewtons of load. And on the second column, we have 500 kilonewtons of load. So that's done. The load is applied. So now let's do the analysis. So let me go to XY plane, and then let me run the analysis part. So click on run analysis and design. So once the analysis is completed, okay, let's check the upward soil pressure. So click on show reaction forces, load combination, dead load plus live load, soil pressure, and then remaining things as it is. Click on apply, close it. So now let's check whether in both footings, okay, whether in both footings, whether the value is less than 100 or greater than 100. So first, let me check with the first footing. So what is the value in the first column? It is minus 198. Okay, it is minus 198. So let me check in the second footing also. Let me move the cursor. Right. Now can you see what is the value in second footing? It is minus 125.61. In first footing, in first column, it is minus 198, and in second column, it is minus 125. In both cases, it is greater than 100 kilonewtons per square meter. Okay, so you can see in first footing, what is going to happen? Uplift is going to happen. Why uplift? How I'm telling it is uplifting? Because the value, the negative value is getting changed to positive value. You can see at the edge of the first footing, if you consider this as the first one and this as the second one, at the right edge of the first footing, you can see the value has got changed to 53 from negative value. Negative value is 198 at the column, and when you move, it is 53. That means in the first footing, uplift is going to happen. And in the second footing, the value is negative only. Even if you move the cursor, it is all negative. On any point at any corner, it is all negative. But it is not within the limits. So both foundations or both footings are risky now. So to avoid this condition, what we need to do is we need to draw the strap beam. We need to connect these two columns with the strap beam. That's what we have to do, right? So that part we need to do it now. So in order to model that one I'll start it. I'll do it in the next session because it take some time. So I'll do that in the next session. So modeling of the strap beam. Okay, we'll define the beam from the next session, and then we'll run the analysis and we'll check. Same process, nothing much changes, right? So that's from my end for this particular session. In the next session, we are going to draw the strap beam for the strap footing design. Right. Thank you.